point, what is basic wind speed? Basic wind speed is generally calculate the peak gust as the applicable to the basic wind speed is actually applicable to 10 meter and above the mean ground level for different zone of the country, and basic wind speed is based on the peak gust velocity averaged over a short time interval of 3 seconds. We have earlier discussed V instantaneous is equal to V mean plus V bar. This is the variable part. And this variable part is called gust. And for design calculation, we take average of 3 seconds of fluctuation of wind speed. The peak gust velocity is the highest instantaneous speed during a gust. Height measured above, generally we take the basic wind speed at height above 10 meter or greater than 10 meter, and gust speed measured over 3 seconds. That means we are taking this value, and this value is for this value is measured over 3 seconds. That means V1, V2, V3 and divided by 3 is equal to V dashed, and V mean plus V dashed is called basic wind speed. Basic wind speed. Now this is clear, and it is taken over 50 years of return period. So in this diagram, it is clearly marked that where the variation of basic wind speed. Now come to the next topic. This is the graph, and for less than 10 meter, in case of less than 10 meter, we discuss in later chapters. Now how the design wind speed is calculated. The basic wind speed VB, the basic wind speed is VB, shall be obtained by from the figure 1 shall be modified to include the following effects of design wind speed: Vz at any depth Z, the risk level, the terrain roughness and impedance factor for a cyclonic region. Now have a look on these factors, in which case we are taking this value, and we have to observe which value is less than 1 or greater than 1. So VB is equal to basic wind speed, and Vz is design wind speed at height of Z. Then Vz is equal to VB into K1 into K2 into K3. VB is the basic wind speed, and K1 is the risk factor, 2 is the terrain roughness and height factor. We will see in the clause number 6.3.2, and K3 topographical factor and K4 is importance factor. And less than 10 meter, for less than 10 meter, for less than 10 meter, for less than 10 meter, we decrease the VZ value by 20%. So now discussed about it is totally clear now the how to calculate the VZ and the risk coefficient K1. Now it is here it is said that the basic wind speed for terrain category 2 as applicable to at 10 meter height for ground level from above ground level for 15 years mean return period. Now what is return period? What is return period? To describe about this, we have to know we have to know the wind data for T years. So once in T years, once in T years, the design wind flown over this area or a particular area. That means the probability of flowing the design wind is P equal to 1 by T. That means if I take T is equal to 50 years, the chances of flowing this is 0.02. How it is coming? 1 by 50 equal to 0.02. This is the probability, and T is the return period. Now it is clear that applicable at 10 meter of 50 years of mean return period, the suggested light period to be assumed in design, and the corresponding K1 factor for different class of structure for the purpose of table 1 in the design of building and the structure. A regional basic wind speed having 15 years is given in the table 1. That means a regional basic wind speed having a mean return period shall be used except specified in table 1. In the design of building a regional basic wind speed having a mean return period of 50 years shall be used except as specified in the table 1. Now we have segregated this value in category 1, category 2 and category 3. Category 3 is the exposed open terrain, that means 1.5 meter height less than 1.5 meter height, and the equivalence aerodynamic roughness we will discuss about it. It is actually how, what is the meaning of aerodynamic roughness? It is actually the how the surface is. Suppose this is the surface and wind is flowing over it, the surface roughness affects the wind velocity. So it is actually the surface roughness. So various codes have specified different value of roughness coefficient. For open sea, we will take it as 0.002, for small grass 0.001, and for urban areas 0.1 meter. And for category 2, we will take it as 0.02, and for category 1, we will take as 0.002. It is clear. Now, how the aerodynamic roughness affects. So this is actually the actual calculation of basic wind speed when the we will discussed in the last few pages, within few pages of IS 875 part 3 2015. Vz at the wind velocity at z height, u star is the friction velocity, the surface roughness, and von Karman constant, and aerodynamic height is z0. We will take for category 1 z01 is 0.002, and for category 2 0.02, and category 1 is for the obstacle height is less than 1.5 meter height, less than 1.5 meter height, and this is actually sea coasts and flat plains without trees. This is the category 1, and category 2 is 1.5 to 10 meters, 0.002, and category 3. So this is the criteria of measurement. Basic wind speed represent open parklands 1.5 meter, 1.5 meter to 10 meter. So built up outskirts of towns and suburbans areas. Open land adjacent to the sea coast may also be taken as category 2. In the sea coast, we will take as category 1. Near cities near sea coast is category 2, and after that we will take it as category 3. So the category 3 is the terrain with numerous closely spaced obstructions such as urban areas up to 10 meter height with zero or few isolated tall structure. The equivalent aerodynamic roughness is 0.2. This category represents well wooded areas, shrubs, towns and industrial areas full of partially developed. It is likely that next higher category, this is not exist in most design situations. It is likely that the next higher category than this will not exist in the most design situation. That means category 3 is the highest. So for category 1, we will take it for category 1 we will take it as sea coast flat planes Z01 is 0.002 meter. This is aerodynamic roughness coefficient. Category 2 is Z02 shrub areas is 0.02 meter, and for category 3 is for 0.2 meter. So evaluating the equation, evaluating this equation, it is very much required, as you can see, and the factors we also know in the latter chapter. Now these are the table. This is the table for all general buildings or structure. We will for 50, most probable 50 years, 33, 39, 34 of for basic wind speed, 47, 1.0 for all general building. For all general building, we decrease at 1 no decrease, no there is no decrease in all general building. Temporary shades is for 33 0.82, for 39 0.76. If the wind velocity is 33, the for temporary shades or structure, for temporary shades or structure for temporary shades or structure 0.82, 39 0.76, 44 0.73, 47 0.71, 50 0.70, and 55 0.67. Temporary shades structures such as used during the construction operation, for example formwork, false work, structure during the construction stages or boundary walls. Building a structure presenting low degree of hazard to the life, 0.98, 0.92, 0.91, 0.90, 0.89. Important buildings such as hospitals, communication tower for 100 years of design life, 1.05, 1.06, 1.07, 1.07, 1.08, 1.08. The K1 is based on the statistical concept which is taken into account of the degree of reliability required in a period of time. Larger the return period ranging from 100 to 1000 years associated with larger period of exposure may have been selected for exceptionally important structure. That means it may exceed the storm exceptional violence. So we can see that the design life of the structure is increasing and the risk factor also increasing. That means whenever there is larger return period 100 to 1000 years, the lower risk level in association with the larger period of exposure may be have to be selected for exceptionally important structures such as nuclear power plant, satellite communication, satellite communication, equation given below. In such cases, K1 factor for different period of exposure and chosen probability of accidents. The probability level of 0.63 is normally considered sufficient for the design against the wind effect, and K1 corresponding to the risk level are taken above. The K1 value is calculated by X and P. This is the statistical concept we will discuss in the later chapters. So N is the mean probable design life of the structure. Pn is the risk level of n consecutive years, nominal value 0.63. The probability level is normally considered for sufficient design of building a structure against wind effect. And X and P extreme wind speed for a given values of n and Pn. And X and 50 is N50 and Pn is 0.63. A and B are the following. Now these are the value of K2. These are the value of K2 we will take for design calculation. We will discuss in the later chapter.